What if I told you the universe is being pushed apart by something we can't see, touch, or fully understand? A mysterious force that makes up nearly 70% of everything, yet remains invisible. Yeah, I'm talking about dark energy, the biggest cosmic enigma out there. But what is it really? Why is it making the universe expand faster and faster, and what does that mean for the future of everything we know? Grab your curiosity because today we're diving deep into a mystery that's literally shaping the fate of the universe. Are you ready to explore the unknown? What is dark energy? Have you ever felt like the more we learn about the universe, the less we actually know? Well, dark energy is the perfect example of that mystery. Scientists say it makes up nearly 68% of everything in the universe, yet we can't see it, touch it, or directly detect it. So, what is it, honestly? We don't fully know. But here's what we do know. Something out there is pushing galaxies apart, faster and faster. And that something is what we call dark energy. Imagine blowing up a balloon. You expect it to slowly stop expanding as the air fills it, right? But dark energy? It's like the balloon is speeding up the more you inflate it, defying expectations. That's exactly what the universe is doing. Instead of slowing down from the pull of gravity, it's accelerating outward. It's wild. Some think dark energy might be a property of space itself, like empty space still has energy. Others believe it could be a new kind of field or particle that we haven't discovered yet. Whatever it is, it acts like an anti-gravity force, stretching space over time. And the craziest part? It's everywhere. Right now, as you're watching this, space is expanding even in the vast emptiness between galaxies, and dark energy is driving that. So yeah, it's invisible, mysterious, and it's changing how we understand the very fabric of the cosmos. The more we search for answers, the more it pulls us into its mystery, just like it's pulling the universe farther and farther apart. Discovery of dark energy. Okay, let's rewind to the late 1990s, a time of chunky computers and questionable fashion choices. Astronomers were studying supernovae, those dramatic explosions that mark the death of massive stars. The plan was simple: measure how fast the universe was expanding and see how gravity was slowing it down. That's what they expected. But what they found? It flipped everything on its head. Instead of slowing down, the universe was actually speeding up. Imagine expecting to see a car decelerate after going up a hill, and instead it starts zooming faster, all on its own. That's how bizarre it was. Scientists were stunned. Something unknown was pushing the universe apart, and that something was quickly named dark energy. This wasn't just a tiny discovery, it was a cosmic bombshell. Two independent teams, both using different data, came to the same jaw-dropping conclusion. The expansion wasn't just continuing, it was accelerating. And suddenly, all those neat theories about a balanced universe, tossed out the window. In 2011, the Nobel Prize in Physics was awarded to the leaders of those teams. Why? Because they basically rewrote the rules of cosmology. This discovery didn't just suggest a new force, it demanded it. And that force is dark energy, mysterious, unstoppable, and quietly shaping the entire universe while we're just here, trying to keep up. The role of the cosmological constant. You know what's wild? Einstein may have accidentally predicted dark energy more than 100 years ago. And then called it his biggest mistake. Yeah, really. He added a term to his equations called the cosmological constant, thinking it would keep the universe static because back then, everyone believed the universe wasn't expanding at all. But when Edwin Hubble showed that the universe was expanding, Einstein scrapped the idea thinking he'd been totally off. Turns out, he might have been onto something big. Fast forward to today, and scientists have brought the cosmological constant back from the grave. Why? Because it might just explain dark energy. Picture space itself having a kind of built-in energy, a quiet, invisible pressure that doesn't fade with time. That's what the cosmological constant represents. A steady, constant push that fills space and drives the universe to expand faster and faster. It's like a cosmic thermostat set on expand, always pushing outward no matter what. And it's not affected by matter, temperature, or time, just there, humming along in the background of reality. Some scientists think dark energy is this constant force Einstein once described. Others think it could be something dynamic, something that changes over time. But here's the big takeaway. Even when Einstein thought he was wrong, he may have glimpsed one of the universe's most powerful forces. The cosmological constant is now a leading contender in the race to explain the invisible hand stretching our universe apart. Crazy how science can loop back around like that, right? Dark energy versus dark matter. Let's clear something up because these two get mixed up a lot. Dark energy and dark matter are not the same thing, not even close. They may both sound like mysterious sci-fi terms, but they do completely opposite things. Imagine dark matter as the universe's glue, while dark energy is its great escape artist. Dark matter pulls things together. It's the invisible mass that helps galaxies form and stay intact. Without it, galaxies would fly apart because there wouldn't be enough gravity to hold the stars together. We can't see dark matter either, but we know it's there because of how it bends light and affects galaxies' movements. Think of it as the unseen hand keeping the cosmic dance from falling apart. Now, dark energy? That's the rebel. It doesn't pull, it pushes. It drives galaxies away from each other, accelerating the universe's expansion like a cosmic engine with no brakes. While dark matter works on local scales like within galaxies, dark energy works on the grandest scale imaginable, affecting the entire universe. Here's an analogy. If the universe were a cake baking in the oven, dark matter would be the flour holding everything together. Dark energy? That's the yeast, making the cake rise faster than expected. So yeah, dark matter is pulling the universe in, dark energy is blowing it apart. Two invisible forces, two cosmic mysteries, both completely changing how we understand space, time, and everything in between. The impact on the universe's fate. Alright, let's get deep for a second. If dark energy is real, and all signs say it is, it's not just tweaking the speed of our universe's expansion, it could be deciding the fate of everything that exists. I'm talking about galaxies, stars, planets, even atoms. Yeah, it's that big of a deal. So what happens if this dark energy keeps doing its thing forever? We might be looking at the big freeze. Sounds dramatic, right? But it's more like a slow fade. Galaxies will drift farther apart, stars will burn out, and over trillions of years the universe will become cold, dark, and silent. A frozen cosmos. Forever. But hold on, it gets even more bizarre. What if dark energy doesn't stay constant? Some theories say it might get stronger over time. If that happens, we're heading straight toward a terrifying idea called the Big Rip. Picture this. Galaxies tearing apart, then stars, then planets, then, eventually, you. Even atoms wouldn't survive. Everything gets shredded by expansion itself. It's like the universe hits the gas pedal and never lets go. Of course, there's also the opposite idea. What if dark energy weakens or even reverses? Then gravity might take over again and cause a big crunch, pulling everything back together into a dense point. The whole universe would collapse on itself, maybe even leading to a new Big Bang. No pressure, right? Just a mysterious, invisible force quietly deciding the ultimate ending of reality as we know it. The truth is, we're still in the dark. But one thing's clear, dark energy isn't just a background character, it's the main act in the story of the universe's destiny. Ongoing research and theories. Let's be real, dark energy sounds like something out of a sci-fi movie. But scientists around the world are working non-stop to figure out what it actually is, and they're getting creative about it. Like, seriously, next-level creative. One of the biggest efforts is the Dark Energy Spectroscopic Instrument, or DESI. It's mapping the positions of millions of galaxies to see how the universe has expanded over time. Think of it like taking a cosmic time-lapse. The more we learn about how galaxies moved in the past, the more we can understand what dark energy has been doing. But DESI isn't alone. The Euclid mission by the European Space Agency and NASA's Nancy Grace Roman Telescope are also joining the hunt. They're aiming their eyes deep into space to catch clues about this invisible force. Scientists are hoping to figure out whether dark energy is constant, like Einstein's cosmological constant, or if it changes over time like a rolling wave. And then there are the mind-bending theories. Some physicists think dark energy might be connected to quantum fields. Others believe it could point to a hidden dimension or even support string theory. Yeah, the one that talks about tiny vibrating strings making up the universe. Here's the bottom line, dark energy is the biggest unsolved mystery in modern cosmology. We don't know what it is, we don't know how it works, but we know it's real. And it's rewriting everything we thought we knew about the universe. The more we search, the stranger it gets. And honestly, that's what makes it so thrilling. And that's the strange, fascinating world of dark energy. An invisible force that might just decide how the universe ends. Crazy, right? The more we learn, the more questions we uncover. If you found this mind-blowing or even slightly unsettling, you're not alone. Space is full of mysteries and we're just getting started. So, if you love exploring the unknown, don't forget to subscribe to Space Facts for more deep dives into the cosmos. Until next time, keep looking up, because the universe has way more secrets waiting to be discovered.